Hi, Chris Good here, and we're going to go over some practice t-tests, and we're going to start with the one that we did in lab. Last week it's the related samples t-test, problem 20 in your Gravetter Wallnau text. So here, this is the one where we're using a matched subjects design, and we're looking at whether single people who own pets are happier than singles without pets. So we've matched 20 and 29-year-old non-pet owners and with a similar age group of pet owners, and they've been matched on income, number of close friendships, and general health. They're not the same people in each group, but because we matched each pair on all of these variables, we can use the related samples t-test because they're related by matching. That means that instead of looking at means for each group individually, we're going to calculate difference scores, right? And each one of these is a D for difference score. So we're going to subtract non-pet owners minus pet owners, right? And copy and paste that to get our difference scores. And what we're trying to do is find out if the mean difference score is significantly different from 0. So we're going to average our difference scores to get this mean difference score. All right? Okay, so the statistic is going to allow us, the t-statistic is going to allow us to see if this is significantly different from 0. In a null hypothesis testing situation, the first thing we're going to do is state the null hypothesis. So in this case, we're not concerned with two means, we're only concerned with one mean. It's the mean difference score. We have a sample mean difference score, which is big M sub big D. But what we're interested in is that hypothetical population mean difference score mu sub D. And we hypothesize that if there's no difference between these two groups, that population mean difference score is going to be 0. The next step is to set your alpha, right? And so in this case, alpha, just like usual, is 0.05. And we need to look up our t-crit, right? But in order to do that, we need to find what our degrees of freedom are. So I'm just going to do that over here. We'll use n, degrees of freedom, and we'll compute those using Excel. N is just the count of all of your different scores. And degrees of freedom is just the number of different scores you have minus 1. Okay, now we can look up t-crit for 5 degrees of freedom, and we'll go to the t-table. We're doing a two-tailed test, as usual. If you were doing a one-tailed test, you'd look in this column where the proportion in two tails combined, the proportion in one tail is 0.05, but here we're looking at proportion in two tails combined at 0.05 with 5 degrees of freedom, 2.571. So the t-crit at 5 degrees of freedom is 2.571. Next is calculate t, and in order to do that, we need to get, the first thing we need to get is the sum of the squared deviations of these difference scores from the sample mean difference score. So we're going to subtract the mean to get deviations. Now don't get confused, deviations are not difference scores. Right? Deviations are the difference between a difference score and the mean difference score. So deviation is the difference score minus the sample mean difference score. And we'll refer to that when we copy and paste. We'll make that a static reference so it won't update dynamically. Okay, those are deviations of each difference score from the mean difference score. Now we need to square those deviations. Just raise that to the power of 2. Now we can sum those squared deviations of each difference score from the mean difference score, and get sum of squares as 30. Now we can get the variance of the different scores. That's just the sum of squares divided by degrees of freedom. Variance is always sum of squares over degrees of freedom. And then we can get the estimated standard error of the mean difference score, right? And that's just the square root of this variance divided by n. It's the square root of the quantity variance over n. I can already see that this is going to be pretty easy. Square root of the variance over n, and that gives us 1. So t is going to be pretty easy. It's just the mean difference score divided by the estimated standard error of the mean difference score, or just the mean difference score itself. It happened to work out this way. It's one of those textbook examples. Now we can make our decision, and the decision is separate from the interpretive sentence that I'm going to ask you to write on every t-test that you ever do and every hypothesis testing statistic we ever do in this class. So because, oops, I found a mistake. This should actually be plus or minus 2.571. It is a two-tailed test. Don't know if you caught that before. Now, can we compare minus 2 to minus 2.571? Let's go back here. You can imagine in two tails, right? This one is minus 2.571. This one is plus 2.571. And minus 2, our t-value is going to be here in the body of that distribution. So we're going to fail to reject, and we're going to conclude that we did not detect a significant difference in happiness between matched pairs of pet owners and non-pet owners. Then we got to report our t. So put a comma. T at 5 degrees of freedom is our observed t-value, minus 2. And the p-value that's associated with, we don't know what it is. I mean, we could do it in SPSS. It'd tell us what p specifically is associated with the t-value of negative 2. But we do know that if minus 2.571 and plus 2.571 flank just 5% of the area under the curve in the two tails combined, that p is going to be greater than 0.05. It's greater than that because it's in the body. And in the body here, right, this is greater than those two combined. Okay. That's it for this one, and we'll see you for the next problem.